Today we're out in the backyard at the shed, and I'm doing something I've wanted to do for a long time. In our community, we have a municipal utility. And what that means is that if you want to do any type of green power initiative, like you want to put on solar or you want to do wind power, it's cost prohibitive because the municipal utility won't allow you to get a loan or to do any type of financing program to do that. So if I wanted to put solar on my house, it would cost me out of pocket about $30,000, which is not what I'm going to do. And I've always been curious about wind because we always have a westerly breeze blowing through our yard because we're in a valley right near some mountains. And I figured wind power might help a little bit. So I wanted to start off small and I wanted to start off cheap to see if it was doable. And I can't put a tower, a 30-foot tower with a windmill on it because, again, that's not allowed according to our municipal utility. But I can do a sort of micro wind turbine, and that's what I chose to do. And I chose to do it, like I said, on the cheap, but of course cheap is never cheap. The turbine itself cost me $170, but then all the ancillary stuff, like I've got to get the piping, and I've got to dig for the concrete base, and I've got to get the charge controller and the dump load and all this stuff. I've been learning as I go along. So I'm going to be up around $1,000 that I've spent to do this. And all I really want to do is I want to get the shed to be self-powered. Originally I was going to run a line from the house, dig a trench and run a line out. But I figured if I can do it with a wind turbine and just have some power there as I need it, then in the long run it would be a lot cheaper and I'd feel good about myself because I've been doing it green. So let me show you what I've been doing on the inside, and then I'll show you what I have to do on the outside. And like I said, I've been learning as I go along here, and it keeps getting more interesting as I do this. So come on in. There's the turbine. Like I said, it cost me $170, so it was remarkably inexpensive for a turbine. And when I ordered it, it claimed to come with the charge controller, which is really important. Most of these turbines for wind are AC, so it puts out alternating current, and with 3 wires you then have to run it to a rectifier to convert it into DC to make it usable power. And when this arrived, there was no charge controller. So I contacted the company and they said, oh, we changed the specifications. We have a generator in there now instead of an alternator, so it just puts out DC current, which is not as efficient as AC current. Luckily, I'm not running that far, so it won't matter as much, but still, it was a little disappointing. But what this is called a Savonius style turbine. And the nice thing is it doesn't have to orient itself to the wind. These are all made of vinyl, so they're fairly durable. And it just spins whatever direction the wind happens to be blowing from. And that is going to be mounted to the outside of the shed in the corner up there. And outside, I will run the cable through the wall and then down, and it will all come to this panel here. And I've got this steel sheet that I'm going to cut and fit and put on standoffs on here, which will help ground it and dissipate heat. You notice I have the junction box here. So all the lines will come in through the junction box and get distributed from there. And the junction box will also go out to an outlet. So I'll have an electrical outlet in here, and I'll have an electrical outlet outside. And I will also have up here a light in the shed, which is nice. And I've already installed a switch over here, the outlet, the box for the switch. So I'll have a light switch I can turn on. And all of that, the power, you say, well, where's the power going to come from? It doesn't actually come from the turbine. The turbine runs in here, and the charge controller is a distribution system that then shunts the power from the turbine off to a battery. And the battery is actually what controls the power. And the battery I got is underneath the shelf here. It's a 12-volt deep cycle battery, 100 amps. It weighs 65 pounds. It's a heavy sucker. And that is what the turbine will charge. And the charge controller then will figure out how much charge the battery has, how much has to go into it. And the charge controller needs, for a wind turbine, it needs what's called a dump load. It needs a massive resistor that will fit in there, so that excess energy the turbine's producing goes to the resistor and heats it up, and so the extra energy is dissipated as heat. Otherwise, if it kept charging the battery beyond what the battery could handle, the battery would blow up, and that would not be nice. So, still got a lot of electrical work to do. I haven't even started that, but that's the way it's all going to work when it's done. Out here, you notice I've already cut these pipes down. Now, when you just saw them, they were 10 feet. That's all I could get from Home Depot. And those are a little too big because the shed is 10 feet tall, and I don't want a 20-foot high turbine. I just want it basically to be a little bit above the peak of the shed. So I cut these down to 7 feet each. That'll give me 14 feet. And you notice I drilled a hole up in this one, and I have a waterproof and weatherproof conduit that goes on there, a flexible conduit that screws into that, and the wire will run through there, and then the conduit will go out into the inside of the shed. And it will all get mounted over here. You notice I have these brackets that are used for antenna mounts, an antenna mast. The bottom one I discovered, that doesn't work. That's used if you have a small antenna post. It's actually in an upside down position right now. If it were flipped around the other way, the antenna mast would sit on top of that and then go up through there. I'm not going to need that, so I got to take that out. And over here, there's an old stovepipe. And what's going to happen is I'm going to dig a hole here through the trap rock, set that stovepipe into it, put the post in, line it up and level it, fill it with concrete down here, and let it set, and that post isn't going to be going anywhere. So that's the plan. Oh, she blows. It's up. It's a good height. A little bit of wind, nothing spinning yet because nothing's hooked up, obviously, and I don't care. And then the wire going into there, and there's the coupler, and there's the concrete, which should set up nice. And that part of it is done. It's up. Now I can concentrate on the electrics. So just for ha-has, while I'm waiting for everything to come in, I decided to hook up a VU meter to see what I'm getting for current off the turbine in a mild wind. And as you can see there, it's registering about, right now, about 90. It's going down, it's going down, it's going up. But these are all millivolts. So it's producing right now millivolts. A moment ago it was about 3 volts when the wind was a little stronger, and it really depends. Now the wind's blowing a little harder, and you can see it jumping all around there, but it's producing very little current. And if I check the amperage on it, as you can see, we're producing milliamps. Almost nothing is coming in there. If I switch to milliamps, so you got about 8 milliamps, 10 milliamps, 5, 4. So current is really low. Not hopeful. At least I know it's working, and that's a good thing. But it's certainly not a stunning amount of electricity coming from the turbine unless we get a hurricane. Now here comes a nice strong wind, so you can see it go up. It's at about, ooh, it jumped to 4 volts there for a second. Now again, I'm going to be charging a battery with this. I'm not going to be trying to run anything off of it. So we'll see. I'm not too hopeful that this is going to produce a ton of current, but hopefully it'll keep the battery topped off. That's all I want. I did get a inverter, which I needed. I got that at Harbor Freight, and I'm going to be able to mount it onto the panel, which is now covered with steel. So we have a little progress, little by little. And we'll see how much current this thing really produces once I get everything hooked up. One other thing I keep forgetting to mention in all this is that the turbine, when I bought it, advertised itself as producing 4,200 watts, which it will never do. That's a maximum rating if it was in a hurricane. And I'm not worried about it ever getting that high or ever blowing out the battery. But the whole reason that I was putting this in was because I wanted to install a garden railway in the backyard, because I've got enough room for it, you know, just going around now that the big pine trees we had here are gone. They had to be cut down. So I figured I'd put a little garden railway, and I needed some way to power it. So I figured, well, a turbine would be a nice way to power that, since it's a fairly low amount of current that it needs. So we will see if this is able to produce anything that will be able to power a flashlight. Who knows? So a lot of progress now. Pretty much all the wiring is done except for grounding. So I can't power anything up until we get grounding, but there's the controller, the Xantrex controller, and following the directions on the website I put in the description, or the YouTube link I should say, put in the description. I come out from up there where the turbine comes in, come down, and then I take the positive from the turbine into this auto reset breaker, and it comes out from there, and it goes directly down into the battery bus bar that I have here. And then I have the positive out from this, or I should say positive in, and that goes to another breaker, which then goes into the bus bar over here. And I also have in the positive the output into the inverter, which will give me AC electricity. So that's that. And there's also over here the PV out on the Xantrex goes into either side, it doesn't matter, but I use this side as the positive since it was closest. The idea here is you want to keep all of your wire runs as short as possible. So I'm trying to keep them really short and at the same time bend them, because these are all 4-gauge wires, so they're very stiff. So got that going into the PV positive there, into there. And then on the negative side, the negative output from the, or I should say the neutral output from the turbine goes directly into this bus bar, and then we come out from the negative here, and that goes into this bus bar as well, and then we come out from the other negative here, and that goes into the dump load here. And then both of these, oh, and also I have this one here, it's directed behind because it was a long wire, but this comes out of here and then goes up to the top, and it goes into the negative terminal of the inverter. And then these massive wires here are going directly down to the battery. And those are not hooked up yet until I get the ground. Once I get all the ground fixed, I'll do that. And the ground is going to be connected to the pipe with this. This is a ground pipe collar, and the big ground wire will go into there, and then the pipe itself will be the ground, and I'll send a wire in through the bottom here, and it'll come up and it'll be attached into the ground here, and this is the ground for the inverter, and there's the ground for the turbine. So all the grounds will be connected and we'll be off and running. So once I get all the grounds connected, I'll be able to fire this thing up and see what's happening. So stay tuned. It's gently raining out. As you can see, the turbine is spinning fine. And if we go inside, there we are. Everything is wired up properly. All the grounds are connected. I even put back the junction box that I had taken out. Is it a little dark for you? Well, let me shed a little light on that. Yes, we have electricity and we have light. The switch is all working. Everything is working great. And if we go over here, you can see the turbine is producing Zippo for power. Nothing, nada. The battery is down to 12.4 volts from 12.8 when it started. So it's draining and nothing is replacing it, nothing is replenishing it. I thought this might be all connected wrong somehow, so I took everything apart and I re-looked at everything and I followed all the connections. No, it's all put together correct. I think it's just a really crappy turbine. So I did check with the multimeter again, and yes, the turbine is producing, 1 to 2 volts of current at about a 1/4 amp. That's about it. And I just don't think it's enough to replenish the battery. So after all this, looks like I've come to a bit of a dead end. Missouri Wind and Solar online sells an entire kit with all of this and the turbine for about $1,000. So if I'd started at that point with Missouri Solar, I would have had a better turbine and I would spend about the same amount of money. So this has been a great learning experience, but a little disappointing because I thought I'd end up with a better result than this. I mean, at least I got electricity, so I know the inverter's working and I know it's drawing power from the battery. That's pretty simple, actually. But why this turbine is, even in a strong wind, producing nothing, I have no idea. So, back to the old drawing board. Well, we're still holding steady at 12.4 volts in the battery. We're up to 0.7 amp hours of usage, or I shouldn't say usage, I should say 0.7 amp hours generated. And occasionally you'll see the array load current go up to 1, and then the watts will go to 12, and then it'll go back to 0. And that happens once every so often. But I mean, it's a sort of a good sign that the battery isn't draining rapidly. Then again, there really isn't any load on it. But I think I'll write this up as a failure. Now, I did check into Missouri Wind and Solar to get a whole new system, but their system uses a 1.5-inch pipe for a fitting instead of a 2-inch like I have, which means I'd have to get a whole new post or I'd have to get an adapter for it, and I don't know if I want to go through that. I might just keep this system for a while longer and see how it goes. The company did write back to me and said they're looking into this. It shouldn't be this way. It should be generating more power, and they're looking at it, but I don't have much hope that they're gonna find much. So what did I learn from this little excursion? Well, I learned that wind production is a tricky business. It isn't as easy as I thought it was. I thought the breeze that we had coming across here was going to be enough to spin a turbine and produce energy, and it isn't. I also learned that you can't really trust turbine manufacturers to give you the right specs on it. The only way really to find out is to pick up the turbine and hold it. The weight of the turbine is what's going to determine how powerful it is. That is a very light turbine. I had no trouble getting it set up there. And you can see the hub is fairly small. That means it doesn't have much in the way of magnets in it, so it's not going to produce much energy. It's simple physics. The heavier the magnet and the bigger the coil, the more energy you'll produce. It also means the more resistance to turning it has, so the more wind you need. I'm starting to understand why wind production is not that big, except on the coast. So if you're on the coast anywhere in the world, you generally will have a steady breeze coming off the ocean, and that's really good for producing a lot of wind power. But here, you can see it spinning, but that amount of spinning doesn't produce enough to create any usable energy, even to charge the battery. So, where to go from here? Well, as you can see, I've got this nice south-facing roof on the shed, and I could put some solar panels on there, and I would generate far more electricity with the solar panels than I would ever generate with that turbine. And I can keep the turbine up there, so that way if it's a cloudy day but there's a lot of wind, the turbine might produce a little something to keep the battery going. But if I want to power my little garden railway, I can't rely just on that turbine. It's not going to produce enough to keep the battery up to snuff. So I guess the next step would be to look into getting some solar panels up there and then tying that into the system. And I will not get them from an eBay place in China because I don't trust them anymore. It is a pretty turbine though. It looks really neat when it spins. And like I said, the turbine didn't cost much, but the learning curve was very steep, and I paid for it in my ignorance. So thanks for watching this. I hope it helped you somehow if you were thinking about a wind turbine. And you can get really good wind turbines, just not this one.